whatever it is, you need to think about it, okay? I never keep track. It's for you guys to keep track. I just read them, right? Yeah. Right. Thank you. Okay. Somebody still take their cards to me? No. Okay. Experiment 21, you'll be doing the KSP. You guys know what KSP is, right? Solubility product. One is the KEQ as well, right? I'll try to give you yes. Yes.
It's the window. Window.
The window.
Is there a way to close the window? I don't know. Sorry, I can't climb up. I'm not a witch. Maybe you think I am. Huh? I have no idea. Oh, somebody found that girl's face. Okay, is that better? I don't want any accidents. Okay?
Stand on a chair.
Gentlemen,
Stand on a chair.
sufficient though? The light needs to go back up. Everyone Halloween to begin already?
Yes.
All right. So you're doing a KSP, right? Your goal is to find the equilibrium constant for the dissolution of a weakly soluble salt. Copy this equation down. Calcium iodate, if you forgot what iodate is, it's IO3, the charge is -1. So taking photos is very, very non-conducive to learning on your brain. Copying is a good way to do learning. Please be aware, X is the concentration at equilibrium, and it will be half of the amount of iodine. In this experiment, you will be determining, is that helpful to mark that? That's very important piece of information. Okay, I'll come back to it. But when you have calcium iodate dissociate, for every calcium iodate, I have 1 calcium, and I have 2 iodate. In this experiment, you will be determining the concentration of iodate, and you will be looking for calcium to do your KSP. Times iodate squared. You following me? Or is that I always wonder if I'm transmitting and you have the reception mode on your ears on or not. Are you hearing me? Yes, thank you. Okay. Can I move up? No. Just a bit. Okay. First step you need to do is to make your calcium iodate salt. You will be preparing that in the lab, okay? Because you will be needing to make a saturated solution of it, okay? So the lab manual will tell you how much of calcium and iodate in solution they'll be provided. You're going to mix them up, okay? You first make the salt. You're going to make the salt. You're going to have it in a centrifuge tube. You guys know what a centrifuge tube is, right? It's like a test tube. And it goes to a point. But you will be using the centrifuge. It looks like that, okay? So you're putting calcium, iron, and okay. So I'll go into more detail in a minute. So you make the salt, then you place it in water and let it reach a liquid. But before you do that, you're gonna have to do several washes. Okay? I'll go into that a little bit more detail. You're gonna prepare the saturated solution without the salt, which means without any solid. Okay? And then you will determine, you can determine either the calcium content or the iodine. In this lab, we will be calculating the iodine, doing this kind of complicated system. Copy this down. Copy reaction 1 and reaction 2. Okay, the stoichiometry was going to be important.
And you know what? Remember this. She might question on those kind of things, right? You have to remember the detail of the experiment. Okay? That's like salicylic acid was like looking and people forget what's done. Then you can come up with it. So these are important equations that you must realize. Okay? Because it's all in your manual. But it's just that there's so much detail in the manual, you don't really see what is essential.
Your titration will involve thiosulfate, okay, to determine the iodine concentration. I'll go into detail on that. So circle your thiosulfate. This is your thiosulfate. If you don't know what thiosulfate is, write it underneath here. This is your thiosulfate. The green one is your thiosulfate. That's going to be your primary standard. Thiosulfate. Okay? So far so good? Everybody got that down? Right from here? Okay. What you will be doing there is you will take your iodate and you will put in acid and sodium iodide, I believe. And all that will happen will be that the iodate will be, I don't know, oxidized or reduced. What the iodate is probably going to be reduced to iodine. Iodide will be oxidized to iodine. That's a redox equation happening. Okay. Then your iodine you will add starch to this solution. Starch and iodine forms a blue complex. So when you prepare your solution to be titrated, you will be having I'll tell you how to prepare your solution. Iodate, and you'll be adding HCl and iodine. And then you'll form the iodine, you will put in starch in your solution, and you'll have a blue solution. The blue solution, that's why I put the iodine in blue, because that will be a blue, deep, dark blue solution. You will titrate that until the blue all of a sudden disappears. Okay? All right? So far, so good? Okay? So, titrate with thiosulfate, which is a good primary standard. Titrate until the blue goes away. Remember, 6 moles of thiosulfate equals that. How do we determine that? Okay, I'm going to write it based on the equation. You will be, when you finish, your thiosulfate is your primary standard. So you will be preparing a primary standard. That is what you're going to put in your burette to do your titration. Since you prepared that standard, you have the molarity of your thiosulfate, right? Okay. And then you will titrate it with a certain volume of your thiosulfate, right? This concentration, since you prepared it, you have the mass, you know how much you diluted it to in a volumetric class. So weighing this substance has to be weighed where? What balance are you going to use? Primary standard, you always have to use the balance in the balance room because you need it to 4 decimal places, right? So you have a good molarity to figure out. So this will give you the moles of the thiosulfate, right? How will I determine based on this equation the mole of iodine. Okay? This is known from this, right? So you're gonna do this, right? And you say, I have 2 moles of thiosulfate is equivalent to how many iodine? 1 of iodine, right? Because you're trying to get mole of thiosulfate, 2 mole of iodine is what you're looking for, correct? So how do I know that? You use the reaction 1, right? So it's 3 iodine gives you 1 iodase. Based on your balance equation, correct? So the mole of that is divided by 6 gives you the mole of your iodine. You following me? Are we good? This is just straight pure stoichiometry when you have a balance equation. Okay, then you have to divide it by how many ml it is coming from. Are you following me so far? Okay. Okay. Nobody should have, right? That's how I wrote half. That's half. Right? Okay, first thing to do in lab, you're gonna get the 2 ml pipette. Pipette. You're gonna dry that. Now, this is the danger zone. For people who aren't here, watch those people because you're gonna air dry it. You're gonna wash it, rinse it. There's an air hose tap in the nozzle. There's an air nozzle. In your lap, there's an air nozzle. You're gonna put the pipette up against it and let the air flow. Now, if you don't hold on to that pipette and you let it go, you're gonna kill somebody. You have a missile though. So watch those people who are not here today. When you put it up against it, you turn it on. Hold on tight, unless you wanna be in jail afterwards. You following me? Hold on tight. Then you set it aside to dry some more, right? While you're doing that, okay, that's the first thing, because that is what you're gonna do to get your sample. Since you're preparing only a small sample, we have no extra. Let me finish. To rinse that pipette. That's why we're making you dry it well. Okay, question.
During the last one, instructor said when we use that air, it's risk of contamination.
Yeah. Yes, there's oil in there. We're doing a little shabby work. Well, not really. Okay. Yes, there is a risk of contamination, but it depends on how low a level of contamination you're worrying about, right? For this lab, we can get by with a little bit of grease because we're titrating for the thiosulfate, right? So it's better dry than wet because that will change your concentration. The oil probably won't matter much. Okay? All right. So you're gonna make, so carefully and do. While you wait, you can do part A, B, and C. Make a solution of sodium thiosulfate. Okay? It is in your manual. You're going to determine what is the mass of thiosulfate you need to weigh out to make your standard. I would consider double checking it with your teacher that your calculation is right because I'm finding students doing funny business in their calculation still. So it's always good to verify that. Okay? Your manual says weigh to certain amount, but like I say, it's a primary standard. The balance to use is in the balance room. Okay. You're gonna make your part B and C. You're gonna make your calcium iodate solid. First, you have to make it solid, right? And then allow it to coolbrate in water. So when you are putting it in my centrifuge is gone, you're gonna have it in your centrifuge tube. You're gonna put the solution here. You're gonna end up with some solid in here and liquid. You're gonna shake that well so that it mix well. You're gonna do this a couple times. Your warm hand might warm up your tube, so your solubility will be different. So what we say is put a paper towel around and shake it, okay? So that you don't transmit the heat too much to your solution. You're gonna do this and then you're gonna decant. Decant means you're gonna pour out the liquid part, okay? And then without the solid. So you're gonna carefully do that after you have centrifuge. How many of you have used a centrifuge? You all know that you need to balance it, right? If somebody's going to use the centrifuge, put one on the opposite side, because if you're spinning something lopsided, you're gonna break the tube. Well, not too bad. Our centrifuge don't spin that fast that it could break. But centrifuges, when you put in one side with a tube with liquid in it, the other side has to be balanced. Okay, there might be spare tube in the lab. If nobody's using it, you can borrow a tube to counterbalance it. Put a little liquid that's about the same amount to balance it. Okay? If not, you can wait for the other people. So typically, okay, when you're making it, the manual says potassium iodide, but I think in the past few years we've been using sodium iodide. It's a certain concentration, I think something around 0.3 molar or something, how many ml. So that part is not so critical, because if you have excess of one of the other, it's fine, because we're gonna centrifuge it down, we're gonna spin it down, you're gonna pour out the liquid, you're gonna add more water, you're gonna wash this a couple times to make sure that any unreactive sodium iodide or calcium, I don't know what calcium form we use, I don't remember, is going to be eliminated. So all you have is calcium iodide, and the source of the calcium and the iodide is just coming from dissolving of the calcium iodide. So you're gonna do several washes. You'll be standing there doing this, a whole bunch of you. You wanna you're gonna centrifuge it, and the manual doesn't say where to put the setting on the centrifuge. You put it sort of at 4 on the centrifuge, and you spin it for a minute. You wait for the minute when you feel you're gonna hear the spinning sound when it's at full speed. 1 minute at full speed. All right? So you're gonna, if all solid, if at the end, okay, there's a final time where you're gonna put in water, and that will be the water that you're gonna put in is the saturated solution of your calcium iodide, right? Because that's what you're trying to do, is that it has to be in equilibrium. There should be some solid. There should be some calcium plus iodide. So the source of your iodide and calcium should be purely from the dissolving of this, right? So if at the end, the last amount of liquid you're going to put in to get your sample, and there's no calcium iodide, I'm sorry, you have to start from the beginning. Okay? Because it has to be, the sample you're going to pull out has to have some solid in it before you pull it out. Okay? Now you're going to the last bit, when you centrifuge it down, that's going to be the sample you're going to titrate. You're going to use a clean, disposable pipette and transfer it to a beaker without pulling any solid out with it. Are you following me? You good? Because it should be just the saturated solution that you're going to titrate. All right? Okay? I believe you have something in the order of 10, 12 ml totally. You will be using then the dry pipette to pipette 2 ml sample into the different flasks for different trials on your titration. Are we clear? You're clear, right? You will pipette your saturated solution without getting any solid, but there should be solid in it before you pipette it out. And then you transfer it to a beaker, and then you're pipetting with that. So the first sample that you pipette out may not be the best quantity, because that's your sort of a rinse of your first pipette. So mark that as your first. If the data doesn't fit the rest of the other 3, okay, you can say, perhaps my pipette wasn't as dry as it should be, right? So pipette 4 samples with a dry pipette, because you have a small amount of sample, you can't rinse the pipette. You're gonna titrate all 4 samples with the sulfate solution. So each of the sample gets, this is in your manual, you're gonna add potassium iodide to it. You can weigh it 0.5 grams, you can weigh it to 1 or 2 6 feet. It means you don't have to go to the balance room to weigh You following me? You can use the back balance to do, because we're throwing in excess KI anyway. So it's about 0.5 is good, but you need to weigh it, all right? So, and then you start solution, this example. Have you been ready before you can add, so that you titrate? Because once you add the KI in, iodine tends to sublime. It tends to go to vapor. So solid iodine goes to vapor. So you need to titrate it within 5 minutes of adding the KI in. Are you clear? Yes? Yes? KI converts your iodate to iodine. If you have iodine with the starch, some of them will lose if you wait too long to titrate. Got it? Good. First sample is a test run. All four should take the same volume of thiosulfate. So moles of thiosulfate equals how many moles of iodate? That's what you're going to convert. Calcium iodate gives you that. So moles of iodate that you determine should be how many moles of calcium. That's in the beginning when I got you to copy those equations, right? You all good? Then you solve for KSP.